let's see what that spam is that's just come up for me. No, I don't need to see that. No problems at all. So there we are. We're live, and so my job here is to walk us through the quantitative assignment, and that's exactly what I'll do right now. So there is one. For those of us who expected that we were going to be able to submit this afternoon, I probably need to have I need to clarify this for you. Okay. Remember, if Cullen makes a mistake, the students benefit. Okay. So if it turns out that you've gone ahead and done your assignment according to what was written in the original assignment guidelines, I guarantee that I'm going to be stricken with guilt, and you're going to get great marks in that particular area. The stricken with guilt thing is that if you look at the existing assignment guidelines under this attitudes and preferences, those numbers there were showing as Q11 to Q19 as well. But no, I'm looking at it right now that Q4_1 to 4_7 is what it is. It's a small thing, and when I looked at Rano, I hope it's okay for you, but maybe it's not. Those of us who've already done our analysis, but if you had been looking at the walkthrough that I had done about this time last year, I had done the right thing. It's just a typo sitting in there. But this Q4 to Q4 to 4.7 is certainly worth having a look at. But anyway, this data relates to a case study, as you know, which is the backyard barbecue. The story begins, fast food restaurant chain. And it wants to know where we're headed. In particular, we want the management wants us to talk about the restaurants that are being visited, understanding the consumers, what the consumers, the profile of the patrons, whether families or singles visit backyard barbecue, consumer attitudes and preferences. Data reduction, so that factor analysis process, and I did see that Rano had done the data reduction. We actually did the piece of analysis the other day, so that was that's something that we'll recover again, and building the outputs of the data analysis into a regression. So that's the cream on the cake is this one. Performing a regression analysis using extracted factors and those earlier 4.1 to 4.7. Let's have a look at this stuff. So where we are on, let's go in, have a look at Qualtrics. And as I said, if you don't have Delhi Depot, the Delhi Depot data set looking you in the face, then you probably need to go back either to the mini lecture support Qualtrics series or earlier on, actually even the last intensive, I'm pretty sure, where I showed us how to bring the data in. But if I key in Delhi, and there's our Delhi Depot data set. Yep. Thanks. You saved me. No end of pain. Thank you. Yeah. Hand on heart, Cullen makes a mistake, students benefit, but I didn't go too far down the road there. So yeah. The data that we're going to use is backyard barbecue build. So there's our data set. This is not how we normally build a questionnaire. I really just built this as an entry screen for the backyard barbecue. There's a whole bunch of things that we could have done, should have done an entry code like a landing page, welcome, lovely to talk to you, all of that sort of thing. But what we have here is all the data landed in. Of course, what we can look at is the reports. One of the first reports we can just begin to eyeball the data. So restaurant visits per month, and we can see that out of the 300 people, 48 of the people had one restaurant visit a month, 101 had 2 visits per month. So a quick eyeball of the data can take us through dollars spent per visit. There's our, what type of frequency table do we call that? A one-way or a two-way frequency table? Of course it's a one-way frequency table. You're only looking at one variable. All right, what's another name for a two-way frequency table? Crosstab? Well done, people are killing it. So a crosstab or a two-way frequency table is the first level of analysis that we're going to look at, and that's pretty much all the stuff that we do on question 1. Here we go. Restaurant, fast food restaurant most visited. McDonald's gets 133, 44%. Kentucky Fried Chicken, KFC gets. That's cool, isn't it? It's, did anybody notice that Burger King and Hungry Jack's are the same? So it's a bit wacky looking, isn't it? But never mind, I didn't build the names. So anyway, let's pretend that Burger King and Hungry Jack's are different restaurants, but they're all just names anyway, aren't they? So we look through, we see the data look like that. The rank importance, if we don't have to, but if we look at the question, that was a drag and drop. What order in what order do you place the importance of these things? That's question 4.1 to 4.7. So that's the offending data that we had. Okay, so we're looking at data. We asked them through, how much do you agree with this stuff? Friendly employees are definitely agree, definitely disagree. Let's go back and look at what we need to be doing. Consumer behaviour. Which fast food restaurants are generally visited by the respondents? Look, for goodness sake, what we've got here, generally, where are we? Fast food restaurant visited per most often. That's pretty much the first output that we need. That McDonald's and KFC, all of that sort of thing, I suppose I should create a, where are we, hub sessions, questionnaire rollout. Let's do this one. So in here, look at that. Look at what we've just done. I copy and pasted that to there, and we ended up having visits, fast food restaurants visited most often in the last 30 days. If I copied that, how cheeky am I? I haven't even had to do any work yet. Look at this. I've got that. I've got McDonald's. I've got 43%. I'll tell you what I might do. I might bring this down here. No, I won't. Stop that, Cullen. What I'll do, this is what you can do to answer the first part. I think if you just did insert, not pivot chart, insert a column chart, you'll probably end up getting something that works. Oh, look. There's one of your first outputs. Just taken without doing anything in Qualtrics, one of your first outputs is this stuff. Now, yes, you need to tidy up. You need to tidy up your presentation. You want to label your axes. I would probably do format axes, and I would axis labels next to axis. Yeah. Anyway, I would end up labeling my axis because that doesn't say anything, but somehow we need to label that axis to say percentage of respondents. This chart title has defaulted nothing in there. It's just defaulted chart title. I'll tell you what I would do. I would take that off and put that in. All of these things. This is what I would do. Tidy that up. and begin to make it look less crappy. To be honest, and I'll leave that to you. Dressing up dressing up an Excel sheet might not be what we minimum access value. I just got to find where we've got the labels. No, can't find it. But at least from here, your first thing to do is build an Excel chart that looks okay. And once you've done that, you've pretty much dealt with question 1A. That is, well, no, you've done the first half, generally visited by the respondents. So the one-way frequency table is the first part of part A. Are there gender differences in the restaurant visited? What are we doing with it? Oh, you're already answering the question. But what's the tool that we use to be able to look at the gender split between the restaurants visited? We've just looked at a one-way frequency table. Perhaps we should, if we want to split it by gender, look at a two-way frequency table or a cross-tabulation. So let's go back to this. We're looking at reports and data and analysis and cross-tabulation, crosstabs. So back in our Delhi Depot data set and under data and analysis, not reports now, but under data and analysis, we go to crosstabs. And I'm going to create a new crosstab because I can't remember what I had. Oh, I had done it. Gender and fast food restaurants visited most in the last 30 days. I'm going to make that the rows, and I'm going to do down here gender. So that's the building a crosstab. And when I hit create crosstab, and here we go. What we've got here is McDonald's 87 and 46. So Hussein is saying no, there aren't gender differences. I'm wondering, look at the picture we've got here. Female, 87 of the females, 46 of the males. 25 went to KFC, 48 versus 20 went to Burger King, backyard barbecue, 13-25. So I get a feeling that there's something going on there. Does that sound all right to you, Hussein? I get a feeling there's something going on there. Cross-tabulation, so the feeling that there are gender differences as we go through this. I get the feeling that there's a picture. There is a statistical test that runs on this, and it's called a chi-squared analysis. So we say, I get the feeling there's a picture here. 87 plays 46, 25 plays 17, 20 plays 48. I get the feeling there's a picture here. I wonder if that generalizes to the broader population. And so we look at the chi-squared test, and the p-value is 0.00. Actually, so it's less than 0.05. What do we think that means? That this is a real difference. Short answer, there's your 1A answer. Chi-squared test returns a value of 0.00, which gives us strong statistical support for the argument that there is a difference between males and females. But of course, you can copy that. You can, I'll tell you one thing you can do. You can create row percents. I just went up here, data options, create row percents. And you say, wow, the profile of the sample, male, female, 50-50. And when we look at this, we've got 65 against 34, and then 40 against 59, and 29 against 70. So that's one of the first things. And one of the things we can do, we can export that as an Excel sheet. And here it is, Backyard Barbecue Build Crosstab. And before we know it, This is going to open up for me in a moment. Before we know it, I've exported that, and it's opened up that crosstab, which is just exported into an Excel sheet. Here it comes. Here's my crosstab that I just created. So that's the raw data that's come out, and from here we can decide that we're going to build build a column chart. So let me just flick through and show you this. I'm going to take out those percentages, but you make your own decision about how you build this column chart. Actually, sorry to bore you with this. It's actually the percentages I'm going to put up there. So I'm going to drag those percentages up and build a bar chart for you. Quick look at this does highlight all of those, and I'm going to take out other. I'm going to leave other out for the moment just because I'm being lazy. But if I highlight that, so I've exported the crosstab, I highlight that, and if I run a column chart on that, insert column chart, wow, we've created something that with a little bit of tweaking is going to give us a picture. So we've exported the crosstab and we've said the percentage of, somewhere in there, remember, label your axes, take the chart title out, do your labeling outside of the chart in your Word document. But wow, the picture I get here, females go to McDonald's, males go to KFC, males go to Burger King, males go to Backyard Barbecue, females go to Hungry Jack's. So that's part 1A. You can, if you're understanding what we're talking about with the chi-squared test, then you can say that this pattern generalises across the broader population. Where's our next part of the question? How much money patrons are spending? And so part B in there, part B in that question, that is question 2. I'll come back again, have a look in this. Dollars spent per visit, I'm going to put that in back to crosstabs. Dollars spent per visit and restaurant, actually I'm going to put dollars spent per visit there, and fast food restaurant visited most often in the last 30 days. So that's another crosstab that I can create. If I hit create crosstab on that, it gives me a look at that. I don't like the look of that. That's a clumsy measure. I've had many students do that and tried to make sense of this in crosstabs. I think the best way to do this is probably looking in SPSS. So let's get our backyard barbecue build up in SPSS. I knew that we couldn't run with Qualtrics and Excel for too long, but what we need now is to pull it up in SPSS. So I'm seeing a lot of people with SPSS live. That's good. Remember, if you're in trouble with it, then you go to data and analysis, export data, export legacy format, SPSS, and then you'll end up having an SPSS file on your desktop. I'm not going to do that because we've been doing it for the last 3 weeks, but I'm in the happy position now of being able to open up an SPSS file. Remember what the question says though? The question says, how much money do patrons spend when they go to a fast food restaurant? What we do there is we look at means. So if we go back into our SPSS file, question 2, dollars spend per visit. If we just look at analyze, compare means, so our dependent list, question 2, dollars spent per visit, and our independent list is fast food restaurants. Let me just confirm. Actually, I'll hover, see what that has to say. Yep, fast food restaurant visited most often in the last 30 days. Now this is new stuff that's not sitting in the old walkthrough that I did. But there's our independent list, dollars spent, fast food restaurant visited in the last 30 days. And when that runs, it gives us an output that says, remember what the scale was here. Dollars spent per visit, $2, $2 to $4, $4 to $6, $6 to $8, $8 to $10, okay? So that's what our scale is looking like. We are dummy coded pretty much on a scale of 1 to 8. So what we're getting there, when we look at the output that we created, we're getting average spend for McDonald's 2.5, average spend for KFC 3.05, average spend for Backyard Barbecue 6.13. Do you think that's a difference? And the question is, the answer is, it looks like a difference to me. So Backyard Barbecue is getting a score of 6.13. Everybody else is getting scores around the 3 mark. Okay, so you've got that's a finding for you. Now there is a statistical test you can do there, and that's an independent samples t-test. Let me just do that with you. Analyze, compare means, paired samples t-test, and I'm going to do this. Dollars spend per visit? No, it's no, it's an independent samples t-test. I'm sorry, team. So compare means, independent samples t-test. The test variable is Q2. Dollars spent per visit. The grouping variable 1, 2, 3, 4 is, for instance, if we're going to see, is there a significant difference between Backyard Barbecue and what's the next closest? Burger King. So Backyard Barbecue is 4, variable number 4. Burger King is variable number 3. So the yeah, that's right. And fast food restaurant most visited. Yep, fast food restaurant visited most. Define the groups 3 and 4. And what that does then is say compare Burger King with Backyard Barbecue. Are these statistically significant differences? When we hit the go button, it runs the test, and we look at the significance, the two-tailed significance. The significance is showing there as a number that's less than 0.05. Anyway, so that's us working through question 1 of that. There's plenty more to do. Where we did that comparing, analyse, compare means, independent samples, t-test, and we did the dollars spent comparing Backyard Barbecue and Burger King. We could be comparing 1 and 4, 2 and 4, 5 and 4, 6 and 4 as the comparison of means. That's something that we hadn't put in the last walkthrough that we did. I know this is all a bit one way, and I know I prefer to be in a bit more of an interactive approach, but let's see where we travel. So that's about how good are the pictures you can draw. So question 1 is about, can we draw pictures and do a few statistical tests? Consumer profiling. Compare results for so the profile of their patrons and families or single people mostly visiting their outlet. So the first thing we can do is we can in our SPSS we can decide that we're only going to look at Backyard Barbecue. So the thing that we can do there, remember we've got fast food restaurant visited in the last 30 days, and these are our variables. What we can do is we can split our data set, and we select cases. The first thing I would do here, data, select cases. And what this is going to do is going to take everything else out and only look at our profile of customers, which is what we're being asked to do. So fast food restaurant visited the most, and what we do here is we're not going to select all cases, we're going to select if the condition is satisfied. And we're going to select if fast food restaurant visited the most. Actually, I need to just confirm. Fast food restaurant visited the most is Backyard Barbecue is 4. So when we do this, data, select cases, and then we come fast food restaurant. If fast food restaurant visited the most equals 4, that's going to select only the people who said, I went to Backyard Barbecue, that was my place. What this does for us now, if we hit continue and OK, and come back to our data, and that's our variable view. If we look at our data view, look at all those crosses through the data. Somebody's done it, thank you. Someone's keeping up. And if you're not keeping up, I'm not hanging trouble in your direction. It's just that this is something new, and you might need to go back and have a look at it. But what we've got here is we've selected out all of the people who didn't choose Backyard Barbecue. If I come to this, and there we go. So that's if I hang over that, fast food restaurant visited most often, and then that's 4. So yep. So what this does now, anything we do once we've got this filter on, is only talking about Backyard Barbecue. And so when in our SPSS, when we look at, analyse descriptive statistics, now that we've profiled now that we've decided we're only looking at Backyard Barbecue, we can just describe the patterns, and we can do that just by doing descriptive statistics and just do frequencies on a whole bunch of consumer demographics. Number of children, marital status, occupation, educational level, ethnic origin, gender, annual household income. So I'll tell you what I'll do, and this is a quick look, and you can go ahead and have a good hard think about this, is all of those are things that I'm interested in. So I'm going to run a frequency diagram of that, and I'm going to create a histogram of it as well. Once I've done that, it'll give me a whole pile of output, and you need to be a bit careful about what that output does, but here comes that whole pile of output. So here's my profile: is that the marital status, that there's hardly any married people, and lots of singles. As far as children go, there's 28% of Backyard Barbecue's customers, and one child, two child. So these are all things that you can use to talk about. Look at the number of people who've gone to who've visited Backyard Barbecue, managerial, professional. So you know, the picture I'm getting there, professionals and self-employeds are people who go to Backyard Barbecue a lot. This is a chance for you to make sense of that data, though. So the way to do that question is about profiling is about selecting the Backyard Barbecue's customers, and then looking at the frequency tables. Yeah. Other ways of doing that. I suggest would be to do cross tabulations. You might choose to go back in, and that's what we did last time around. Was under data and analysis, cross tabs, and if we create a new cross tab, this is the last look. Fast food restaurant visited most often in the last 30 days, and come down and look at, for instance, first cross tab that we can do is number of children, let's say, or marital status. Number of children, create a cross tab, and here's our cross tab that comes out of that. So, yeah, so if I take that out into Excel, there we go. Take that out into Excel, and here's what our cross tab looks like. Yeah, and my guess, I think the selecting cases might be one way of doing it, but I reckon exploring that question too by cross tabs is probably a nicer way for you to do it. Once we've done this selecting cases, I'll just come back and tidy up my data set. Once we've done that selecting cases, let's just click the All Cases button so that it takes all those crosses out. Otherwise, it'll really make your life a little bit unpleasant. So we're back there now with a fresh SPSS data set. So that's a bit of a look at how we might do question 2 by exploring what the data's got for us about family structure. And cross tabs, I think, is a reasonably handy tool for that as well. Let's have let's keep moving on this. Attitudes and preferences. So describing general trends in consumer attitudes and preferences. Hey Rano, sorry about that typo that you'd already fixed up. Did you get ahead of it? Did you already work out that I'd been making a mistake? No, but I hope it's easily fixed anyway. Which attitudes are most important to the consumers? And that's look at questions 4.1 to 4.7. Yeah, cool. So I really reckon 4.1 to 4.7. Yeah. Yeah, I reckon all that we need to do here on attitudes and preferences is do a calculate means on those particular variables. So if we go back into SPSS and we look at the variables 4.1 to 4.7, and we can see that the rank importance of this price, speed of service, convenient location, all of those sorts of things. All we really need to do there is analyse, compare means, take these out because these are all old information, and calculate the average rank importance, and OK, and there we go. Are there differences in the rank importance between so remember, one is high in terms of rank importance. So what we're showing here, speed of service is scoring an average 3.46, and 1 is high. So 1 is the most important. So 3.46 is the highest. Is the most important? No, there we go. Consistent food quality, 2.89 is the most important. Followed quickly by followed a little by the speed of service and menu variety. I mean, what you can do with this once you've calculated those averages is you might choose to copy that out into Excel. Copy that out into Excel, which is what I'm doing here. There's rank importance, price of food, rank importance, speed of service, and you could fairly quickly do an insert chart. And there we go. There is the rank importance. Now, bearing in mind that what you've got here is speed of service is, well, this particular one, rank importance, consistent food quality, is the most important. And so you've got a bit of a backwards thing going there. If you're clever with algebra, you could change those numbers to make it make it look more important. But there's a look at the question 4.1 to 4.7, 4.1 to 4.7, and attitudes towards fast food restaurants. We're back into gender differences, attitudes toward fast food restaurants. So you can get away. No, I would compare the means for each of those things, to be honest. Question 11 to question 19. So the easy way. An easy way of doing it might be, you don't even want to do a crosstab there. I'm quite sure you don't want to do a crosstab. I think what you want to do is calculate the average of question 11 and the mean, compare the means between males and females of question 11, compare the means males and females question 12, compare the means males and females question 13. Let me just walk you through that process. Again, pretty straightforward, but it's a process. So there's question 11. I prefer fast food restaurants that serve healthy, nutritious food. Definitely disagree, generally disagree, all the way up there. So it's a 1 to 6 scale. So the first thing we can do, remember question 11, we can do analyse means and then take these rank importances out and bring them back to statements of preferences. Okay, so I'll just look first at question 11. Prefer fast food restaurants. And if I hit the go button on that, okay, we find that on a scale of 1 to 6, it's an average 2.73. But what we want to do is compare males and females. And so the job to do here is analyse, compare means. Same thing, means, and we've got dependent list. I prefer fast food restaurants. I reckon I saw your comparison of means table. Did you do a comparison of means table there? Yeah, you've killed. Yeah, I think you've killed it. No, it's somewhere up there. I think I'd seen the sort of table that this puts out. So the first one, if we do it just as a single one, we do I prefer fast food restaurants that provide whatever that question was, and the gender we put as the independent list. And now we've done males and females. Males and females are agreeing or rating that as a 2.59, and males are rating that as a 2.87. And the trick you can do as a statistical test for that is an independent samples t-test. So if you do compare means independent samples t-test for question 11, I prefer, where are we? I prefer fast food restaurants that serve healthy food, and the grouping variable is gender. Gender 1 and 2, define groups 1 and 2, and before you know it, we've run a statistical test there that says 2.59, 2.73. I know what I've got. It's yeah, look at this. I defined the variables wrong. It's 0 and 1. My apologies, team. Analyse, compare means, independent samples t-test. Where we've got gender, the grouping variable is 0 and 1. I'm glad we've got this recorded. 0 and 1, it's done 2.59, and then as it runs through and does the independent samples t-test, the significance is 0.1. So we can say it appears that there is a difference between males and females in how much they say they prefer fast food restaurants that serve healthy, nutritious food. When we actually run a statistical test, it gives us a p-value of 0.1, which means that it doesn't generalise to the broader population. We can then go back in and do the same sort of thing with our next variable, independent samples t-test. Take that out. Friendly employees are important. Hit the go button and it runs through. Friendly employees are important. 2.77 plays against 3.79, and when we look, don't pay attention to the Levine's test, pay attention to this significance and the two-tailed significance. So that second one there about friendly employees, there is a significant difference between males and females in how much they like friendly employees. Males say that males rated as 3.7, females rated as 2.7, and that's what our data is telling us. Look, if you want to, you can just jam the whole lot in there. This is one last thing to do. Question 3, independent samples t-test. You can jam the whole lot of question 11 to question 19. Put them all into, holding on that, 19. Put the whole lot into there, and it runs through and does the entire test. And we can just say those are the male versus female, 2.59, 2.87, 2.77, 3.79. So those are the compared means. And then this table is where we scroll down and see if we find significances. There's significance, significance there, no significance there, and there we are. Sorry, I know this is all one way, and I hope you're not going to sleep. So Q11 to Q19, that's about comparing means between males and females. Comparison of means and an independent samples t-test is the test that you do there. I hope that makes sense. Let's get on and talk about data reduction, and that's the dimension reduction in attitude items. We have already done this, but let's do it again. And here's the here's what we're talking about. We've got these attitude items about these are the preferences that we have, and I'll find our data. So question 11 to question 19. So how much do you agree? To what extent do you agree? Scale of 1 to 6 with healthy, nutritious food, friendly employees, coupons, all of those things. So question 11 to 19. So what we're trying to do is work out the clustering of when people are, or what people are thinking is important. I just want to check, have I done this already? Yes, I have. And you might remember yesterday that they clumped out to being about employees, about deals, about food quality, and about nutrition. But let's walk it through again, this thing that we call an exploratory factor analysis. So when we look at this, analyse dimension reduction. So this is question 4. Analyse dimension reduction factor. And we come down to question, I right click, display variable names because I've got numbers in my head, Q11 to Q19. Right click because it shows the labels again. Put that all into the variables that we're interested in. We ask the system to do a rotation which tidies up the data for us, and then we hit continue. And our output comes through and does this exploratory factor analysis. Now we had done this yesterday, but what that did for us, it identified 4 possible factors, and by the time we'd identified 4 factors, we'd represented 88% of the variance within the data set. And the component matrix, we just skim past that, but the rotated component matrix is these 4 things. These are 4 clusters of preferences. So it's hard to understand, it's hard to interpret when we look at it on the screen like that. But if we copy this into an Excel sheet, copy and paste it into an Excel sheet, and I'm using this one. Just going to rename this factor analysis. Copy and paste this into an Excel sheet, and there we go. We've got, so these are the importances. These are the importance items, and these are the factors. And if we remember my little trick, I highlight that and I do conditional formatting, new rule, and then OK. And that ends up giving me a picture of the higher numbers are where these items are correlating onto this factor. So this is covering old ground, stuff that we had spoken about yesterday, but we can see friendly employees, knowledgeable employees, courteous employees. That's a factor where people are indicating that they care about employees. This one, coupons and price promotions, that's a deals idea. The quality of ingredients and consistent quality food, that's a food quality, and this is healthy, nutritious, and salad bars, that's a health factor. So that's what we're looking at there. So I'll just do that. That's employees. Employees matter, deals matter, the food quality, and healthy food. So they're all our factors. Bear with me, let me look at the question again. So there we go. I have pretty much done that question for you right then, that we've done the data reduction, we've performed an exploratory factor analysis, we've seen the importance values clustering into these areas, and we call them, now maybe you can put a spin on it give them names of your own, but there they are. You might change the colours of this or whatever. But that's pretty much us having done an exploratory factor analysis. Now, the one last thing that we need to do though is it says save these as factor scores. Now that's what I had done yesterday, and this is the data set that had come out like this. Yep, so there we go. This was the process of me doing factor scores. I'm going to kill that right now and do it again in front of you, okay? So it's pretty easy, but let's kill it anyway. Kill this stuff. And remember how we got this output that allowed us to do that factor analysis? We did analyze, dimension reduction, factor. The one thing we do differently now, all of this stuff in place, we're using a Varimax rotation, no problems. But what we're doing is scores. We're saving the scores as variables. So each person is going to get a score of how much they are a deals person. And they're going to get a score for how much they are a nutrition person, or whatever those factors were that I created. So if I hit the go button there, it does all that. There's our factor analysis. Same old information as we just had. But the one thing it did do is save as factor scores. And what you end up getting is this. Factor 1.1, 2.1, 3.1. And because we've already done this work in Excel, I'm going to do this. Employees, go back to the variable employees. And to make myself less untidy, employees. Employees. And then it's not employees, we don't want that. The next one was deals, fair enough. So that score that we've created there is deals. Food quality, remember SPSS hates spaces in variable names. So what I'm going to do is food quality V, and I'm going to mess with this food quality like that. And the last one is healthy, and you might call it nutrition or whatever, but that last one is healthy and healthy. Now when we look at what those variables are, if we double click, it turns out these are, it looks scary, but they're really sweet numbers. They're Z scores. All of these have a mean of 0, standard deviation of 1. But you can see that this person, 1 here, this person is really just in the middle, you know, close to 0, as far as how much they care about employees. They're towards the bottom. They're really towards the bottom on food quality, quite a bit towards the bottom on healthy. But then we come in here, this person is really pretty caring about food quality and even more caring about healthy. And as we go through, so these things are all scores about the extracted factors. When we go to that question there, in particular, so when we go to the extracted 4 factors, this last bit here, perform a regression analysis using the extracted 4 factors, that's this stuff. That's the employees factor, the deals factor, the food quality, and the healthy factor. So that's a first quick look at that. Anyway, so that's your part 4 that you can do. Now I've seen people already doing a little bit of that. I've got about 5 minutes, let's say 10 minutes left of doing this. I'm mindful that you've done a marathon with me and it's all been me just going blah in front of you. So I don't like to be in that mode, but at least I can get something put down on a recording for you. Let's go with this last one, association between variables. Remember what we're doing there? Correlations. Remember what a correlation score is? Varies between -1 and +1. SPSS will eat that stuff for you. So if you ask SPSS to correlate, then you're in really good shape. So I am going to, let's do that right now. Is there a significant association between each of these? Now notice that we're not saying, is there a significant association between all of these? Is 4.1 correlated to 4.2, correlated to 4.3, all of that sort of thing. We're not asking about that. We're not asking for a correlation matrix of those items. What we're asking for is, what is the correlation between likelihood of future visitation and each of those fast food selection and consumption patterns. Let me show you the easy way of doing this. The first one, let's do correlation between 4.1 and question 32. So the easy way to do this is analyse, correlate, a bivariate correlation, and let's find 4.1 to begin with. 4.1 and 32. Q32, which is likelihood of future visitation. Likely to return. Alright, so we're just asking it to do just the one there at the moment. Remember, a -1 correlation means it's totally, if people are scoring high on how important the price is, then they would be scoring really low. Anyway, let's see what this tells us. If we run the OK on the correlation, what we've got is a 0.273, and that's a reasonably weak positive relationship between how important price is and the likelihood to return. Yeah, all right. So to be able to look at all of those, but it is a significant correlation. To be able to look at all of those, we can just put all of those in, correlate, correlate, bivariate. I'm going to take all these out because it'll make it tidy, and then include 4.1 out to 4.7. 4.1 to 4.7, and then 32. Now this is going to give us a table. Most of this table is going to be not relevant information to us. Where these are all being correlated with each other, it's just stuff we don't care about. But what we do care about is the correlation of question 32 and 4.1, question 32 and 4.2. And so we're only looking at one row of the correlation matrix. Let's show you the correlation matrix. There's our likely to return. There's our likely to return, and there's our rank importance. And so as we come along here, is there a significant correlation between likely to return and price of food? Yes, there is, and it's a little bit weak. There's a negative correlation between likely to return and the speed of service, strangely enough. So when somebody's rating speed of service fairly high, they're actually rating likelihood to return fairly low. So you can look at that bottom line and interpret what that means. And let's go to the last part of that question. So the result of that correlation analysis, and let me give you a little bit of an insight. When people think speed of service is important, they are weakly not likely to return to backyard barbecue. So there's a bit of a chance that backyard barbecue is not performing in terms of speedy service. When people are saying that convenient location is important, they tend to be saying no, I'm not likely to return. It's weak, but it's real, and so maybe the location is not such a good thing. But there is a positive relationship between food quality. So they might be looking at, gee, I think food quality is pretty good because I'm going back. Positive relationship with menu variety. So they look like they're a bit happy with menu variety. And look at this, they're all positive relationships. And a positive relationship with friendly staff. No, a weak positive relationship with friendly staff. Notice that all of those significances are lower than 0.05, so it means they are real, significantly different from zero correlations. The one last thing we can do is a regression analysis. And so those extracted 4 factors, from 11 to 19, and these fast food selection and consumption patterns. Basically saying, can we predict whether people are coming back? That's question 32. Can we predict whether people are coming back based on the things that they consider important in a restaurant, and also in their and also in and these extracted 4 factors, which, let me look at it again. Yeah, so there we go. A whole bunch of consumer drivers, and do they predict the likelihood to return? So let us go to that. This is a fairly another reasonably straightforward process. If we do analyze regression and then linear, remember what we're trying to predict: likelihood to return. So that's question 32, likelihood to return. And the independent variables, come back here, 4.1 to 4.7. And importantly, we don't want to put all of those in. We want to put the extracted 4 factors, and that's what we've done here. The extracted employees, deals, food quality, and healthy or nutrition. And we also put those in there. So we've got a whole bunch of predictor variables that we are hoping are going to predict that dependent variable of likelihood to return. If I hit OK on that, that comes through and tells us that what we've got here, the first thing we look at on this regression output is the significance level. So what we're looking at here is we can argue that none of these rank importances are predictive, because our significance or our p-value is lower than 0.05, and we can also say that employees are a significant predictor and healthy are a significant predictor. So when people are saying that employees are important, it significantly predicts their likelihood to return to backyard barbecue. When they are saying that healthy food items are important, then it significantly predicts their likelihood to return. And the last thing that we can look at is the strength of the relationship, and that is these standardized coefficients. So of the 2 that matter, we've got employees and healthy food items, and employees are 0.887 and healthy food items are 0.175. That means there's a significant and positive effect of employees on how important we think employees are on their likelihood to return, and it's about 4 times the size of how important we think healthy food items are on our likelihood to return. I've got to say that's a lot of data that we've crunched, and I've got it as a recording. The recording hasn't timed out on me, so I haven't gone past 70 minutes, but That's the number crunching. To be honest, this quantitative assignment is a reasonably creative process as well. Students find their own way to make sense of this data. And again, what's the one thing, both with our qualitative and our quantitative assignment, that I want you to be communicating to me? That you're not afraid of having a look at the stuff, that you're not afraid of having a go at it. So here's me for an hour agonizing over data in front of you, saying this could work, that could work, this could work, you could do this, you could do that. And I've got to tell you, a statistician would probably look at me and say, you're crazy. The stuff you're doing is crap. And I would just have to sort of just take that. But what I need you to do is not be like the genius quantitative data analyst. You know, the world is full of those people. What we're doing is a research methods course, and what we need is to not be afraid of our data, not be afraid of doing some analysis. So if you can go in, have a good, honest try at the data, and you're communicating that you're not afraid of trying to make sense of quantitative data, that's what I'm looking for. You won't be failing this assignment, I can assure you, if you have a good, honest go and you try to breathe life into your quantitative data. So there are examples in here. Probably got it here. There we are. So under quant, under assessment, we've got quant. We've got the latest version of the walkthrough of the quant assignment. The first version of a walkthrough of the quant assignment. Guess what? In that one, I'm probably telling you different things to what I'm telling you in this one. Different things to do. And guess what? That's not a problem. Whatever you pick that's going to work, if you answer question 1, 2, 3, 4 and 5, and you honestly are working through the data, then that's okay. If you do a comparison of means or you do a crosstab, yeah, one thing's maybe a bit better than the other. But if you've communicated to me that you're not nervous, well, you might be nervous, but you're not afraid of looking at data and trying to make sense of it, that's what I want us to do. So our quantitative assignments are sitting in there. Maybe I can see if I can find it sitting in here so that we're not dragging it out. Nope. All right, so a quick look at where, at the first example, and I can't remember who did this, but it looked fine. Almost everybody's looks fine. You've got a sample assignment that runs exactly the same, data as we've got, and there he is, Daniel, and what he has done is written it up as though it's a report. You know, he's played a game. He's played the game. He's said, this is the business. This is what we want to be achieving. These are the objectives we'd like to be achieving. These are he's thought about research questions that we've got there, and he's begun to walk through talking about consumer behaviour, drawn me some charts, shown what a chi-squared test result looks like, walked through creating maybe their comparison of means. I can't remember. I think that's yeah. Anyway, and what Daniel had done here is he quite clearly communicated that he wasn't afraid of looking at the data. So I'm not sure that what he did here, a whole bunch of crosstabs, was the perfect way to do it. But at the end of it all, I was pretty happy that he was prepared to write a report and use his data analysis to make sense of, to work towards making sense of the data he had in hand. I'm going to hit the stop button right now. We're way past 3:30, but I'll hit the stop button. If anybody wants to talk to me, I'll stay here for as long as anybody's here. But I do need to go upstairs and re-record that coding module that I didn't manage to record here. And if anybody wants to put their name down for a Wednesday session, then there are still slots here, so you can do that as well. I really hope that early next week I get our research briefs back to us and we can have an idea, and yes, there will be more opportunities to talk to me on a one-on-one basis about where you think your research is going. So we have done a lot. We've come in doing quant, we've spent the middle of these couple of days doing qual, and we finished with me just downloading analysis on quant. But I think we've taken a lot out of it. If you want to chat with me before you leave, then that's good too. Otherwise, it'll be a couple of weeks until we see each other again. Remember, what are we doing between now? Okay, we've got the quant assignment to do, but what are we doing on a daily basis between now and 2 weeks? Coding our in vivo data set. So coding our in vivo project with nodes, cases, relationships. It's going to be a world of pain if we walk in the door without having done that coding 2 weeks from now. So there we go. And good luck with the quant assignment, but I'm not going to hurt your feelings.